Hello everyone. Today I am here to introduce the Lambda expressions and higher order functions in StarRocks version 2.5. A Lambda expression is an anonymous function that can be used as an input to a higher order function. It makes the code more concise, compact, and extensible. Specifically, this is the syntax of a Lambda expression. On the left is the argument that the Lambda expression receives, which can be one or more parameters. If the number of parameters is greater than or equal to 2, it needs to be enclosed in parentheses. On the right is the expression itself. Besides basic expression calculation, scalar functions can also be embedded. They are connected by an arrow pointing to the right. Higher order functions are functions that support Lambda expressions. In version 2.5, StarRocks supports higher order functions for arrays, allowing you to more easily perform calculations, filtering, and sorting on elements within arrays. Currently, the 4 higher order functions, including array map, array filter, array sum, and array sort by are supported. Among them, array map is the foundation of all higher order functions, and we'll use it as an example to explain how to use Lambda functions. The syntax of the array map function is as follows. Each element in array 0 will be calculated one by one according to the Lambda function, and the final result will be returned. The calculation logic of the Lambda function can include multiple other arrays besides array 0, such as array 1, array 2, etc., which only participate in the calculation. Here's an example. Using array map, all elements in the array, in this case 1, 2, and 3, will have 100 added to them, returning an array with values 101, 102, and 103. At the same time, multiple arrays can participate in the calculation, scalar functions are supported, and higher order functions can be nested. Array filter is based on array map with added ability to filter. For example, in the following example, the part where x less than y will be filtered out in the output. At the same time, array filter also supports simple usage of non-higher order functions. It takes 2 arrays as input, and the elements in the second array need to be of Boolean type. Array filter will filter out the elements in array 0 where the corresponding position in array 1 is 1, forming the return value. In this example, the second element is filtered out. Array sum is based on array map with the added ability to sum up. Currently, array sum does not directly support Lambda expressions, but can be nested with array map to be used. In this example, it calculates the sum of the squares of all elements in array 0. Array sort by enhances the ability to sort on top of the array map. Array sort by also supports simple usage without higher order functions. In a common use case, array 0 will be rearranged according to the ascending order of the elements in array 1 and returned. For example, if array 0 contains 3, 1, and 4 and array 1 contains 7, 2, and 1, array 1 will be sorted in ascending order as 1, 2, and 7, so the corresponding array 0 order will be 4, 1, and 3. The higher order function is similar, only sorting based on the ascending order of the results calculated by the Lambda expression. For example, here, it is sorting based on the sum of array 0 and array 1 as the corresponding output. These functions' flexibility enables them to be a handy tool in many analytics scenarios. Let's take a look at 2 very simple examples below. The first scenario is variable capturing. In addition to filtering variables through array filter, variables can also be captured through array map. For example, in the following example, array map makes it easy to capture the subjects in which each student scored higher than their average score from the previous exam. The second scenario is session analysis. Session analysis is a very common type of user behavior analysis. Here, we will take a simple example where we have logged data of a user browsing a website. Now, we take 30 minutes as the length of a session, and calculate the total number of sessions within a certain period of time. Specifically, we convert the timestamp column into an array. Sort it, calculate it, and filter it. Finally, we select intervals of more than 30 minutes for downstream analysis. This makes it easy to calculate the number of sessions, average value, and other indicators. With higher-order functions, you can more easily perform operations such as calculation, filtering, and sorting on elements within arrays. We believe that there are more scenarios where higher-order functions can be applied, making analysis even simpler. In the future, StarRocks will continuously enrich and add more related functions. We also welcome those interested in the StarRocks community to join us. The function task issue list is currently available on GitHub. Both community members who are interested in contributing and those who have related feature requests are welcome to discuss in this issue.